So today we are going to start with the chapter Similarity of Triangles. In the previous class you have studied about the congruency of triangles. Here we will be discussing about the similarity of triangles. Now, what is the difference between congruency of triangles, means congruent triangles, and similar triangles? Congruent triangles, as you have already known in class 9, that the two figures are said to be congruent when they are identical in every aspect. When you talk about the congruency of two triangles, suppose we take two triangles A, B and C, D, E and F. When you talk about the congruency of these two triangles, that means they are identical in every respect. That is, they are the true copy of each other. That means if I place this triangle above this triangle, it will appear only as a single triangle. This is A and as well as this is the point D. This is B as well as E. This is C as well as F. That means if we place one triangle above the other, they will be superposing on each other. That is, they will be exactly the same shape and size. So in this case, when you talk about the congruent triangles, they are having the same shape and the same size. But now our topic of discussion will be the similarity of triangles, similar triangles. Now let us first know what are similar figures. Two figures having the same shape. Two figures having the same shape but mind it, they have the same shape but not necessarily the same size. Not necessarily the same size. The size may vary. The size may not be the same, but the shape has to be the same. Are called similar figures. Okay, so if we take examples, then we can say all circles are similar irrespective of their radii. All squares are similar irrespective of their length of the sides. All equilateral triangles are similar because we know that each of the angles in an equilateral triangle is 60 degrees. So irrespective of the sides of the triangle, we can say that these figures, all circles are similar, all squares are similar, all equilateral triangles are similar. One important thing is that all the congruent figures that we are talking about are similar, but the converse may not be true. All the congruent figures are similar. All the congruent figures are similar, but the converse is not true. So even if two figures are congruent, they are similar, but every similar figures cannot be called as congruent figures, because in congruency there is strict rules that they have to be have the same shape as well as the same size. In similarity, we do have the same shape, but the sizes may vary. So all congruent figures are similar, but it is not the same case with the in the reverse, that all similar figures may not be congruent. Now, when you talk about similar figures, let us now come to the point, that is similar polygons. You know what is a polygon? Now we talk about similar polygons. Two polygons with the same number of sides are said to be similar if number one, their corresponding angles are equal. The corresponding angles are equal, and number two, their corresponding sides are in proportion. This what? Proportion. They are not equal, but in proportion. When the angles as well as the sides are equal, they are congruent. Now here we will be first discussing about the basic proportionality theorem, which is also known by the name Thales theorem. So before that, let us again have a review of this. What are similar polygons? Two polygons with the same number of sides are said to be similar if their corresponding angles are equal and their corresponding sides are in proportion. So polygons, you know the basic. The first polygon that we can talk about is a triangle, three-sided figure, and the two triangles, we are discussing about this topic. The similarity of triangles will come to that particular point when we discuss about the similarity of triangles, when two triangles are said to be similar, and what will be the criteria to prove that the two triangles are similar. So here first we will start with the basic proportionality theorem. Which is also known as the Thales theorem. Now according to this, if a line is drawn parallel to one side of a triangle, intersecting the other two sides, then it divides the two sides in the same ratio. in the same ratio. Write it down, then we'll write the, suppose this is a triangle, we can name it as ABC. Now we draw a line DE parallel to the side BC. So if a line is drawn parallel to one side of a triangle, here we are drawing the line DE parallel to BC, which intersects the other two sides, that is, intersects AB at D and AC at E. Then we can say, so if DE is parallel to BC, okay, the first thing that you can write is that AD by DB is equal to AE by EC. Okay, the first thing you can write AD by DB. So AD by DB equals to AE by EC. So you can apply this directly. Next one is AD by AB equals to AE by AC. AD divided by AB. So this part AD divided by the total AB equals to AE by AC. This is number 2 we can do. And number 3, DB by AB. DB by AB. We have previously taken AD by AB, now we are taking DB by AB equals to EC by AC. So these are the 3 conditions which can be applied while solving the problems, which is the basic proportionality theorem known by the name Thales theorem. If a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. Now from here, according to the Thales theorem, we can write AD by DB equals to AE by EC, AD by AB equals to AE by AC, and DB by AB equals to EC by AC. This can be proved, but we are not going into the proof right now. So this is the basic proportionality theorem. We have also the converse of this basic proportionality theorem. You just note it down, then you write down the converse of this particular theorem. Converse of basic proportionality theorem, it says if a line divides any two sides of a triangle in the same ratio, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Then the line is parallel to the third side. So this is the converse. If a line divides any two sides of a triangle, suppose this line DE divides AB and AC in the same ratio, then we can say that this line D is parallel to the third side, that is BC. Okay, so this is the basic proportionality theorem and its converse. Now we will discuss about the criteria for the similarity of triangles. Criteria for the similarity of triangles. So you can write two triangles are said to be similar if two triangles are said to be similar if number one, their corresponding angles are equal, and number two, their corresponding sides are in proportion. So two triangles are said to be similar if their corresponding angles are equal and the corresponding sides are in proportion, or you can say are in the same ratio. So let us draw the two triangles. So you can very easily can make out that the triangles that I am drawing are having the same shape but obviously not of the same size. So triangle ABC and triangle DEF, what is the condition? Their corresponding angles are equal, that is angle A should be equal to angle D, angle B should be equal to angle E, and angle C should be equal to angle F. So angle A is equal to angle D, angle B is equals to angle E, and angle C is equals to angle F. First condition, if they are similar. If they are not similar, this particular thing does not hold. If they are similar, then you can say that angle A and angle D are equal, angle B and angle E are equal, and angle C and angle F are equal, and the sides are proportional, that is AB by DE equals to BC by EF equals to AC by DF. AB by DE is equal to BC by EF is equal to AC by DF. So these are the two conditions for two triangles to be similar. So if they are similar, then their corresponding angles are equal and their corresponding sides are proportional. And then the way to write triangle ABC, similarity symbol is this one, is similar to triangle DEF. If these two conditions hold, then you can say triangle ABC and triangle DEF are similar. In congruency, the symbol you already know, and this is the similarity symbol. And now we will move on the conditions, how to prove that the two triangles are similar. The first one, AA, or we can say AAA criteria, similarity. Now what does it say? If two angles of one triangle are equal to two corresponding angles of another triangle, if two angles of one triangle are equal to two corresponding angles of another triangle, then the two triangles are similar. Then the triangles are similar. And needless to say that if two angles of one triangle respectively equal to the two angles of another triangle, then the third angle of the two triangles are also equal. Because we know that the sum of the three angles of a triangle is 180 degree. So if the two angles are known and they are equal, the corresponding angles are equal, obviously the third angle has to be equal. Okay? So ABC, DEF, let us take these two triangles, and if we say angle B equals to angle E, or you can say let us angle A and D are equal, angle B and angle E are equal, then automatically angle C and angle F will be equal. So if angle A equals to angle D, angle B is equals to angle E, then you can say triangle ABC is similar to triangle DEF. And when they become similar, then automatically we have the sides proportional. AB by DE is equals to BC by EF is equals to AC by DF. So what is the first criteria or the rule to prove that the two triangles are similar is that two angles of one triangle should be equal to the corresponding angles of the other triangle, and thereby the third angle automatically becomes equal. So if just you can prove that any two angles of one triangle are equal to the corresponding angles of the other triangle, you can directly say that the two triangles are similar, and when they are similar, then this property automatically becomes active, that is the sides are proportional. Second one, SSS similarity. As I have already told you that in case of similarity we are not going to discuss about the equality of the sides, we will be discussing about their in the same ratio. So if in two triangles, sides of one triangle are proportional, sides of one triangle are proportional to the sides of the other triangle. To the sides of the other triangle, then the triangles are similar. So here if you can prove that the sides of one triangle are proportional to the sides of the other triangle, then we can say that the two triangles are similar. That is, if we can prove that AB by DE is equal to BC by EF is same as AC by DF. If you can prove this, that the sides are proportional, that means they are in the same ratio, then we can say triangle ABC is similar to triangle DEF. And once they become similar, then we know that the other condition, that is the corresponding angles, automatically becomes equal. So we have angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Okay, now let us recall the two conditions. First one is the two triangles are said to be similar if the corresponding angles are equal, and the corresponding second one is the corresponding sides are in the same ratio or in proportion. So these are the two conditions for a triangle to be similar. Now, it is not necessary to check both the conditions, mind it. When you are to prove that the two triangles are similar, you just have to check either of this. Either you check the sides are in proportion, or you check that the corresponding angles are equal. If any one of the two conditions that we have discussed right now is true, then the two triangles are similar. It's not that you have to you check that the two corresponding angles are equal, then you are trying to check again whether the sides are proportional or not. You need not check that, because automatically the sides become proportional. The sides comes to the same ratio. So only either of these two conditions that you have discussed right now is to be checked for the two triangles to be similar. Third one, SAS. If one angle of a triangle is equal to one angle of the other triangle, if one angle of a triangle is equal to one angle of the other triangle, and the sides including these angles are in proportion, then the two triangles are similar. So read it carefully. If one angle of a triangle is equal to one angle of the other triangle, and the sides including these angles are in proportion, then the two triangles are similar. So if we talk about angle A and angle D, angle A and angle D are equal. If one angle of a triangle is equal to one angle of the other triangle, that is angle A equals to angle D. And what are the two sides which includes this angle? That is the side AB and AC of this triangle, DE and DF of this triangle. So you can say AB by DE is equal to AC by DF. Then the two triangles are, if this condition and the sides including this angle AB by DE is equal to AC by DF. Then we can say the triangle ABC is similar to triangle DEF. Hopefully it is clear now, the three conditions that we have discussed now about how to prove that the two triangles are similar. The first one is you need the AA criteria or AAA criteria, where you need to prove that two corresponding angles of two triangles are equal. The second one, the sides are in proportion, and third one is the SAS similarity, where one angle of a triangle is equal to the one angle of the other triangle, and the sides which includes these two angles are in proportion or in the same ratio, then the two triangles are similar. Just go through this once again, and now still we have some time left. We can take 1-2 questions. So I am writing the question, you try to answer. Question number 1. Two sides and the perimeter of one triangle are respectively three times the corresponding sides and the perimeter of the other triangle. Write the question carefully, read the question carefully. Are the two triangles similar? Why? Read this question carefully and need to conceptual based. Two sides and the perimeter of one triangle are respectively three times the corresponding sides and the perimeter of the other triangle. Are the two triangles similar? Can you answer it? What will be the answer to this question? Are the two triangles similar? And if it is similar, why they are similar? You are given two sides and the perimeter of one triangle are respectively three times the corresponding sides and the perimeter of the other triangle. So obviously it is very much clear that the perimeters and the two sides are proportional. The perimeters are in proportion of the two triangles, as well as the sides are also in proportion, two sides. So the third side will also be in proportion. The third side will also be in proportion. Perimeters and the two sides are proportional given. The perimeters and the two sides are proportion. Obviously, the third side will also be in proportion. Therefore, the third side is proportional to the corresponding third side. So all the three sides now become proportional, and hence the two triangles are similar. Two sides and the perimeter are respectively 3 times, and the perimeters are in proportion, sides are in proportion, two sides are in proportion, obviously the third side has to be in proportion. So when 3 sides of one triangle are in proportion with the 3 sides of the other triangle, then the two triangles are similar. Okay, today the time is over. We will not proceed further because we need to join the next class, and in the next class we will come up again with more questions based on this particular chapter. But when joining the next class, make sure that you learn the properties, how to deal with, how to prove that the two triangles are similar. The 3 criteria we have discussed about, AA criteria or AAA criteria, where you need to prove that the 2 angles of one triangle are equal to corresponding angles of the other triangle. And once you can prove that, then the sides automatically become proportional. Second one is that you can prove that the 3 sides are in proportion of one triangle are in proportion to the 3 sides of the other triangle. They are similar. In that case, you can say the corresponding angles are equal. And third one is AS. If one angle of a triangle is equal to the corresponding angle of the other triangle, then the sides including these 2 angles are in proportion. So this is about, and the basic proportionality theorem in the beginning we have discussed. So just remember all these. So next time when you join, we will be dealing problems based on this. Till then, have a nice day, take care. Thank you.